Hello friends, in the current video tutorial I will be talking about the working of SR latch and RS latch. SR latch is set reset latch and RS latch is reset set latch. What is a latch? Latch is a 1-bit memory storage element which is made using logic gates, typically NOR and NAND gates. The gates are cross coupled to create the functionality. They are asynchronous sequential circuits. They don't have a clock input. They have two inputs, set input and reset input. They have two outputs, Q and Q dash, which are typically complement of each other. So let's now see the working of SR latch, which is made using the NOR gates. So we have to understand the working of NOR gate first. So we see that the NOR gate is having the tagline that high at the input makes the output low. So high at the input, this one, this one, this one, they make the output low. This is the first tagline. The second tagline is that all lows at the input make the output high. All lows at the input make the output high. So these two taglines we have to remember. Now let's see the working. So if we see the first entry of the truth table, S equal to 1, R equal to 0. So S equal to 1, R equal to 0. So we remember that 1 at the input makes the output low. So because of this, the output becomes low over here, 0 fed over here. The output becomes high because both the inputs are 0. So 1 over here. 1 fed back over here comes over here as feedback. Both ones make the output low. So the output is Q equal to 1 and Q dash equal to 0. So Q equal to 1, Q dash equal to 0. Then the next condition is both S and R equal to 0. So if I mark it as 0, so let me rub this. So S equal to 0 and R equal to 0. So S equal to 0 and R equal to 0. So both the inputs are 0. This is 1 because of both the inputs 0. 1 fed back over here and 1 at the input makes the output low. So 0 over here. So that means no change. No change. Then we have the S equal to 0 and R equal to 1. So let's set the R equal to 1 now. So when I set R equal to 1, when R equal to 1, then what we have? So 1 at the input makes the output low. So this is low. It comes over here as feedback. Now this becomes 0. 0, 0 makes the output high. So Q dash becomes high now. So Q dash becomes high now. It is fed back over here. And because of this, this feedback becomes 1 and 1, 1. Both the inputs high makes the output low. Fed back over here. So Q becomes 0 and Q dash becomes 1. Now this condition is over here. Now the next condition, both inputs R and S equal to 0. So if I mark it, both are 0. So if I mark it 0 and 0, so 1 at the input makes the output low. So this is low. 0, 0 makes the output 1. So 1 fed back over here. So Q equal to 0, Q dash equal to 1. So that means no change. Then the last condition is both S and R equal to 1. So let's put S equal to 1, R equal to 1. So if I put S equal to 1, R equal to 1, so both ones at the input will obviously make the output equal to 0, so that becomes 0, and 1 at the input makes the output equal to 0, so this will also become 0. So we have this condition, both s equal to 1, r equal to 1, we have 0 0. So that comes to the end of this, and let's see the crux of the story now. So crux of the story is, then when we set s means set is made high, then q gets high. Set is made high, q gets high. That is this condition, set q gets high. And the second condition is, then when we set r equal to high, q dash gets high. So r high, q dash gets high. So r gets high, q dash gets high. So this is SR latch because of setting making the q high and resetting making the q dash high. So that comes to the end of explanation of SR latch. Now we will see the explanation of RS latch. SR latch is made using the NOR gates, RS latch is made using the NAND gates. So in the next section we will see the working of RS latch, which is made using the NAND gates. Now let's see the working of RS latch. So before starting to the RS latch, we have to remember the NAND gate truth table and the tagline of NAND gate. So the tagline of NAND gate is that anything low at the input makes the output high, means over here, this is the low. So anything low at the input makes the output high, right? And both inputs or all the inputs high make the output low. So this is the tagline, low at the input makes the output high, all highs at all the inputs make the output low. Now let's see the working of RS latch. So we have S equal to 1 and R equal to 1. So let's put it S equal to 1, R equal to 0. I'm sorry, S equal to 1, R equal to 0. So when S is equal to 1, that means we don't have both ones, so we cannot say right now about S, but 0 at the input makes the output high, right? So because of this the output gets high. So 1 comes over here as feedback, this is fed over here, both the inputs high make the output low, so this will become low, and over here it is fed back. So 0 0 combining make the output high. So this condition q dash gets high over here. Then next condition is S equal to 1, R equal to 1. So if I have this R equal to 1, so I have to make it over here R equal to 1. So R equal to 1 after S equal to 1, R equal to 0, this we have to keep in mind. So R equal to 1, so 0 at the input makes the output high, so that this is 1, this is 1 fed over here, and 1 already high because of this, and this we have the output 0, and over here the output is 1, so means no change, there is no change. Now S equal to 0, R equal to 1, S equal to 0, R equal to 1. So when we have S equal to 0, R equal to 1, then over here anything 0 at the input makes the output high, so this becomes high, so this is fed back over here, then we have this over here as 1. So 1 1 at the input, all inputs high make the output low, so this is 0, and 0 fed back over here makes this as 0. So 0 0 at the input makes the output high, so this becomes high, so Q becomes high and Q dash becomes low. So this is this condition, Q becomes high and Q dash becomes low. Then the next condition is both 1 1, set and reset both 1. So we have to change set to 1. So when we change set to 1, what will happen? 1 0 at the input makes the output high, this is 1 1 1 comes over here and fed back, then we have the output 0 because both the inputs are 1, right? Both the inputs are 1, output equal to 0, and 0 fed back over here gives the output high as 1. So there is no change because of these two ones, right? So remember, this is after s is equal to 0, r equal to 1. Now the last condition is both 0, s equal to 0, r equal to 0. So if we have s equal to 0, r equal to 0, then we have to make the change over here, s equal to 0 and r equal to 0. We have 0 0 over here, so 0 at the input makes the output high, so high over here, and then over here also it is high because 0 is here, so 1 is fed back over here, it comes out to be 1 over here, and so both zeros at the input makes the output high, so this condition is there because of this, right? So the crux of the story, let's now see the crux of the story. So the crux of the story is, let's mark it, set equal to 1, r equal to 0 makes the output q dash equal to 1. Set makes the output q dash equal to 1. Set at the input makes the output q dash equal to 1. And then we have reset, the second condition, reset makes the output q equal to 1. This condition is over here, that reset is high, then q gets high. See, q gets high. So set makes the q dash gets high, reset makes the q equal to high. So that's it for the RS latch. So that comes to the end of the video. I hope you have understood the concepts properly and you have liked this video. Thanks for watching this video and come again.